welcome. It's so great to have so many of you here. I just want to say thank you to Firstmark and Crew Capital for, well, first of all, for hosting us in this amazing venue, and secondly, for helping to organise this event. So, Dylan mentioned 2.0. We've just released 2.0 this week, and later on in my talk, I'm going to talk a bit about what is in 2.0, why it's better, why it's different, and what we've been working on for the last year. But before I go there, I know there are lots of people in this room who are new to SurrealDB and don't necessarily know what it is, why it will benefit you, benefit your workplaces, your organizations, your hobbyist projects, whatever that is. So I'm going to take a kind of jump back in time to where I was back in 2015 and why I started, when I decided to build a database, which is a crazy thought this many years on. So what is SurrealDB? So SurrealDB is a multimodel database. It combines graph, time series, document, and you can query all of those different database types in a nice, easy to use SQL-like query language. The most important thing with SurrealDB is the distinct separation of the storage of the data from the compute that you're running to query that data. So you typically see these in analytics databases, like ClickHouse, like Snowflake, where they separate that storage from the compute in order to be able to scale out that compute as you need. But with SurrealDB, that gives us a number of distinct advantages in both a transactional context and an analytical context. And that means that SurrealDB sits nicely in the middle and can efficiently be used for both types of problems. So the first thing is, as you can scale that storage, you can also scale out the number of nodes and therefore make your database highly available and highly scalable. In addition, everything in SurrealDB is transactional based and ACID. I think all developers have spent their time using databases where transactions were not a part of the software, or where you inserted data and when you came to read that data, it didn't exist, or it wasn't there, or it hadn't synced, or whatever that was. And that leads to an awful developer experience. And over time, different NoSQL databases have improved, they've had transactions and they've added support. But really, if you want to make a database work for developers in a broad array of kind of scenarios and environments, you have to think and start from the very beginning, from scratch, about how you build that database. And for us, transactions were a key part of that. For SurrealDB, it's a document database under the hood. So think similar to MongoDB, but ultimately the developer experience of MongoDB and other databases like that, we think could be improved. And although we didn't want to go right back to SQL and joins, we did want to improve that developer experience and have an SQL-like language. So we'll be looking a bit in this talk about how you query data in SurrealDB and how that can, by bringing these different models of data together, you can really improve how you build your applications. So finally, and I think it's a big topic nowadays, AI and ML. So we've got functionality inside SurrealDB which eases and simplifies machine learning and artificial intelligence pipelines and the processes that you use to bring data and query data alongside your models and your machine learning. And we'll touch on that a little bit as well. Before we go there, though, I still haven't touched on why we built SurrealDB. So back in 2015, I was working with my brother, who is not technical. He's the brand, the image, the pink behind SurrealDB. And we were building applications which, in the traditional sense, and many organizations are still building in this way, we were using time series, we were using document databases, we were using graph databases, we were using relational databases, and we were combining all of these things together in a single platform. So we had a middleware, an API layer that would communicate with the different types of databases. There would be different consistency guarantees on that data. It would be stored and queried in different ways. And we'd have to pull those all out through the APIs and into our dashboards and our applications. And in addition, not all of those databases are transactional based. So you have to ensure that the data is consistent across all those different databases. And if you go back even further than that, the world started out relational, just one type of database. And then into the early 2000s, document databases and graph databases, so NoSQL became popular. And today you have all these different specialized databases, and that's what we were doing. We had a specialized database for time series, a specialized database for graph analytics, a specialized database for document and some relational things. And this is what most organizations are still doing today. And the thing about that is an increased amount of complexity, both in terms of the building of the application, the configuring of the infrastructure, the maintenance of that infrastructure, and often databases focus on speed. So they'll say, look, this performance is 1 millisecond quicker. But when you take the performance of that one query against your document database and you add that to your middleware API layer and you add that to time series and graph, and then you're combining all these things together into a single query, that performance no longer is really relevant. With SurrealDB, we want to do all of those things, and we want to do it as performant as you would get with a single database. And that is the aim of what we're trying to build. So why do you need multimodel? One of the big questions that we get all the time is a database that can do everything can't do anything well. So how are you going to make this work and convince me to move from this database or these databases? Multimodel is about improving the developer experience by bringing all these different types of models together. So being able to very efficiently build on top of the SurrealDB platform by scaling out. So if you need a highly available, highly scalable cluster, and then being able to use performant key value queries or document queries or time series based data, and bring that all into one central platform. Now the difference with SurrealDB's multi-model approach and a traditional multi-model database is that we don't force you to choose your model up front for a particular workload or scenario. We let you choose all of the models at the same time. So that point about performance is even more important there. We'll come down to how we achieve that later. But you can start by putting your data into SurrealDB, and it could be just a set of 5 fields like you would put into Postgres or MySQL. And you can then grow that, and you can add document-based data. So you can add arbitrary nested objects and arrays into that data, and you can query it with the same SQL, very similar to traditional SQL query language. You can then go a step further, and you can start relating your data to other data inside your database. So being able to use graph connections. And then finally, you can query just subsets of that data completely index-free without having to think about performance or optimization or changing your queries. You can query time series-based data from that as well. So without having to think up front about which model you're going to use, are you going to need key value, are you going to use relational, and how you're going to query that, and whether you need schema or no schema, you can start very basic with the concepts that you understand with the experience that you've had, and then grow from there and improve and augment the models and the types of data that you're querying. So document data is great. Obviously, I presume everyone here has heard of or knows or has used even MongoDB. It enables you to store JSON-like object data inside a database and to query nested objects, nested arrays. And over something like a traditional relational database that just has flat fields, you can then have much more expression inside your data. You can have orders and tags, let's say, inside your data as opposed to in other tables. With graph, I think graph is one of the most underappreciated but most important data models out there in the technology space. If you think about the real world, none of us actually think about data in terms of tables, collections, or in a tabular format. We think of things in terms of types. So people, animals, dogs, cats, and you can go more granular or you can go more high level, but everything is a type to us. But then those types are augmented by relationships. So I purchased this light. And that is how our brains think. So when you're forced to think in terms of tables with joins based on integer IDs that link to another integer ID in another table, it's not really how your mind is actually thinking about that data. So in SurrealDB, you can do everything in a tabular way if you want to. you can store your records and you can link to other records and other tables. But where the true power comes is when you store a person in the person table, a light in the light table or product table, and then you can relate that with a relation or an edge, and you say, this is now, I have purchased that light, or I own that light. Time series, I think, goes without saying, very important if you're dealing with event-based data. And then, as I said before, an SQL query language makes sense to developers, engineers, data scientists, anybody who doesn't really have necessarily an engineering background, but wants to query and learn from data. But also for those people who are engineering, have an engineering background, SQL makes complete sense. So for us, SQL was important in this product. In addition, in SurrealDB, we have granular security levels, row level, field level security, and we have support for different authentication types in terms of third-party authentication, single sign-on. And one of the things I'm not really going to talk about in this talk today is the fact that SurrealDB can actually be used as a back-end database as well. So you can connect directly to it from your web app, whether that is an iPhone app, whether it's a web site. You can connect directly to the database, and it only has permission to see the data that that user who is authenticated can see. But I'm not going to touch on that today. And we'll talk about AI and ML later. So how do we get the performance in SurrealDB that you might expect when you're dealing with, when you're comparing us with a document database that just does one thing, or a key value store that just does one thing and very well? So in SurrealDB, we kind of reimagined how you query a single record. And in SurrealDB, a single record is not an integer 1, 2, 3, 4, 5, 6. It's not a UUID. In SurrealDB, the record ID is a table and an ID put together. So you'll see this everywhere through data in SurrealDB. It's made up of the table, which here is the record, and then the ID, which is after the colon. This makes it very efficient to use all of these models at once. So here, I'm creating a record in the temperature table. You see it's very similar to SQL that you might know already. And this will create a random ID for me. So this will work well in a distributed environment where you have lots of writes and you want to have random IDs dispersed reasonably across the cluster. Now, if you want to use specific integers as well, like with a relational database like Oracle or MySQL or Postgres, then you can just specify :1 and other integers after that. Now, in SurrealDB, record IDs can be more complex than that. So we can support strings and UUIDs and other types, which I'll touch on in a minute. In addition, we can specify, and this is important in distributed or very demanding applications where you need a lot of writes or you have a lot of reads. So you can determine whether your data sits next to each other on the key value store or whether it's dispersed across the storage engine and is better in those distributed environments. So random will create a random ID. ULID will create a sequential ID, but based on a string. And UUID, you can choose between v4 and v7, so you can have sequential or random. Now, this is where it gets really interesting, and this is how we achieve time series-based querying inside SurrealDB. Because the ID of a record ID in SurrealDB can also be an array of values. So here we're creating a temperature recording, a temperature entry, and the first part of that entry is the city, and the second part is the current date. Now, there's an alternative way of doing that is using objects, which is slightly more complex, and we'll focus more on arrays. But the point is it's very flexible in terms of how you query those IDs and how you reference those IDs, and then that gives you the power later on when you want to query them. Now, finally, when you're dealing with edges, we have a new clause called relate, and that enables you to add connections between certain records. So here I want to mark that I have written the article called Surreal and set the time to now. And then here I've got two subqueries which are selecting all users from the SurrealDB company and all developers or all users who have the developer tag. And I want to create graph edges and graph connections between the two. Now, The true power of time or array-based record IDs is then apparent when you want to do time-based querying or just filtering without having to build any indexes. So here I'm selecting from person 1 to a person 1000. This doesn't go and look at the table. It doesn't go and look at indexes. It knows precisely where it needs to go on the storage engine to retrieve just those 1000 records. Now you can build upon that and use that within subqueries or within edge relations and graph relations. So you can build on this record ID functionality everywhere around your application. The second query is basically selecting all temperature recordings that have ever been recorded for the London city between the beginning of time, so none, and the current time. The third query is selecting every temperature recording from the very beginning of time, so we have no starting ID here, to a specific date. And then, again, the second to last query is selecting all from a particular date to now, so every single one after that date. And then the final one is selecting between two specific dates. So this enables any developer, without having to plan up front whether they're using a specific time series engine, to actually say, this data I'm going to need to be able to query in a time series way. So I can now automatically, without having to think about indexing or sharding or anything like that, I'm going to be able to pull out segments, and you can make that as granular as you want of your tables or of your data instantly without having to plan up front. Now, where this gets really powerful is when you combine the record IDs with potentially complex array-based IDs and then graph. So what we're doing here is, this is one of the reasons why we couldn't use ANSI SQL. It's one of the questions we get asked a lot. Why didn't you just use ANSI SQL? Why are you writing your own query language? And for us, it's the ability to add graph support into a database without having to build complex Gremlin or Tinkerpop APIs or other things like GraphQL. So for us, we're starting from the person Tobie record, and we're following all edges out, so everyone that he knows, and then everyone else that he knows as the second friend edge, and everyone he knows or likes where they have an influencer equals true tag as friend 3. So what I will get back in that response is 3 fields, F1, F2, and F3, and effectively this is what you can do on LinkedIn. So you can see the third level connections on LinkedIn, and it's just as easy as that. So you can immediately traverse through efficiently all of the records that this person knows and beyond. Again, here's another one. So we're looking at all people in the person table, and we want to find all of the emails that they've ever sent and the people they've sent them to, as long as that person has sent at least 5 emails. So incredibly flexible, easy to define query, which combines your traditional document. So we're starting with the people records. Those are just documents or tables at the end of the day, and then traversing out through other tables. So the sent table, the email table, the to table, and the person table, without really having to think about how you're going to build that. And the third query is an example of a product recommendation engine. So being able to see in real time which products Tobie has purchased. So Tobie has purchased a product. That product was purchased by another person, and those other people purchased a product in the last 3 weeks. That's going to find me all products that were purchased by other people who also purchased the products that I purchased in the last 3 weeks. And that's an incredibly complicated query if you're using something like Postgres or Oracle to do with joins, and or if you're bringing data down from, let's say, MongoDB or another database, and you're combining and joining that data in your application locally. So what can you really do with multimodel? So I've really just touched the surface of how SurrealDB can improve and simplify the developer experience and the applications. And the true power comes with being able to combine these models together. So taking the graph, the time series, and then combining that with other functionality which we have in SurrealDB around machine learning. So in SurrealDB, you can insert a machine learning model. So a machine learning model that you have trained from scratch in PyTorch, or TensorFlow, you can bring that model into SurrealDB and have it sit next to your data. So in the same way that we experienced difficulty by managing the complex infrastructure that traditional applications nowadays have around multiple containers running on Kubernetes with different services and different platforms and many different microservices. The same is true if you look out in the world of AI and ML right now. It's blown up, not just in terms of the popularity of it, but in terms of the complexity of it as well. And for us, machine learning and AI is all about data. The models are trained on data and the models infer on data. So for us, the true place where that model should be inferring on that data is by the data. So you can port your custom trained model right into SurrealDB, and you can then run inference on that data. So you can either pass raw vectors straight into it, and it will run that against the model. And here you can see that you've got different versions of models as well. But the true power comes when you then combine everything else we just talked about with this functionality as well. So here we're running the insurance prediction model, version 1, on the person Tobie record, but we're also pulling in his age field, his income field, rounded up or down, and then the number of properties he's ever purchased. So we know, this is obviously a very rudimentary basic query, but we can then see whether this person may be likely to buy based on their social situation and whether they've purchased before. Now you can do that without having to ever leave SurrealDB. Now what you can then do is you can go a step further. You can say, if you look at traditional triggers or events in other databases, I want to build on that. But I want to build on that and say, whenever this person's record is updated and when the income has changed, so when the before income, before the change was made, is different to the after income, then I want to rerun this insurance prediction model on this person's data, pulling again in their age, income, and the number of properties or whether they've purchased before. And that will then update that user record whenever it's updated and its income is updated. And there you have constant trigger-based, event-based machine learning right inside and next to your data. And we don't even stop there, because what you can then do, that field is stored on the record. So we've now got likely to buy equals true, and we know that that record was updated in the last day. Now in SurrealDB, one of the final pieces of functionality that we're going to look at here is being able to run live events based on the changes to data. So that user's record was updated, the income was changed. An event was triggered, the machine learning model was inferred on that data right inside the database, running on GPUs. It updated the likely to buy field, maybe from false to true. And my application, my dashboard somewhere, is looking at and selecting all users. Now that's a pretty not very useful query, but maybe you're doing an aggregation or a count or doing some analysis on that. What you can now do, you can use the live word and put that just before your normal select query, and suddenly you can listen to a whole train of events of users where the likely to buy field has been changed, and you can then build dashboards or pipelines or workflows based on that. So last week we launched SurrealDB 2.0. This was just under a year in the making, and a year it seems like a long time, but in the world of databases, that is not a long time at all, given that we're only 2 years old. So SurrealDB 2.0, one of the biggest things we focused on in this release is improved security functionality. So being able to support JWKS, JWTs, third-party authentication providers, like Okta and Auth0, and also support for single sign-on from social applications. This actually enables enterprise authentication as well, so being able to connect with enterprise authentication systems to determine what users can or can't do and what users can or can't see inside the database. It pains me because SurrealQL is so powerful, but a lot of users use GraphQL. So GraphQL had to be a feature that we had to support. Now, if you look at a lot of other database systems, GraphQL is a layer. You can run it in Node.js, you can run it in Python sitting in front of your database. But because SurrealDB is a graph database which supports documents and nested data, it made sense to build our engine right inside SurrealDB itself. So now when you start SurrealDB, you can start it with a GraphQL flag, and automatically all of your definitions, your GraphQL definitions, your functions, everything become available at a GraphQL endpoint. You can infer on that data, you can build complex nested expressions and queries. And the most important thing is, this isn't GraphQL running on a relational database that isn't built for graph. This is GraphQL built on top of a graph database that is built for graph. And so when you do anything more than a single join or two table joins in terms of nested data, then with SurrealDB, that's efficient. We don't even have to really think about that. In another traditional relational database, that's going to get more complex and less performant as you go on. We've completely rewritten the parser in this one. It pains me to say it, but the first parser was written by me. And then we hired had this wonderful money injected into us, and we hired some great engineers, and the parser was completely ripped out and rewritten. But it's now more performant. It has a better understanding of the language and where things are going wrong. And it's overall just a lot better than it was before. In addition to that, the core engine has been updated to be able to handle this parser better. So indexing is a kind of massive area with the popularity of vector databases and full text search databases like Elasticsearch and things like that. Obviously, indexing is an important area. But for SurrealDB, again, if you're having to insert data into SurrealDB and at the same time keep a full text search or vector search database up to date and consistent with the data that you're querying and inserting inside your database, that adds much more complexity to your whole workflow. So for us, indexing is not a new type of database. It's not a different type of database. It's a functionality that should be with your database or inside your database. So for us, we have support for traditional indexes, full text search indexes, and vector indexes, including ANN and ENN, so approximate and exact nearest neighbor search. And we've just released in version 2 the support for background processing. So obviously, if you're dealing with large amounts of data, you don't want to have to wait for that to process. So background processing indexes and local memory caching, so it makes everything faster. And then the final thing I'm going to touch on today is in Surreal, we've had to write everything from scratch. We haven't really been able to rely on an underlying database or an underlying index engine. We've had to write everything from scratch, which is hard and time consuming, but it gives us the power and flexibility to be able to offer the different models and the different functionality that we can offer in the future. So one of the things we've been working on over the last year is something called Surreal KV. This is our own key value storage engine, which is effectively a replacement for RocksDB, or if you know out there, LevelDB and LMDB. And the difference is this supports temporal querying. So what is temporal querying? This is time travel effectively. Is time travel the same as time series? It's one question we get asked a lot. So these queries that I showed you earlier today, in Surreal KV, you're able to store every version of data that was ever changed or updated or modified or inserted into the database. And that has incredible power when you want to query that data later. So take the first example. I changed it slightly. Instead of likes, I put trace. So go back to the beginning of the COVID pandemic. I want to be able to analyze all people who have been contact traced by this user. Perhaps that was on an app going near to someone else's app on their phone. I want to check that as of that particular date from this user. Who has he contacted? Who has he been in contact with in terms of first level, second level, and third level, where they were in person? So any in-person meetings. Thinking about that doesn't make sense because it was only in person. But anyway, now this enables you to go back in time and see your data, not just a single table, not just a single record, but your entire database in terms of the relations, the edges, the time series data, everything as it looked like at a particular point in time. Again, here, I want to go back in time and see what this query would have run like and what it would have looked like 4 weeks ago. So I don't have to think about querying different fields or anything. I can just put a version at the end of my query. And the same thing at the bottom. So being able to say, I want to analyze all of the products that this person has purchased and other people who've purchased these products, what have they purchased? So it's a recommendation engine, but I want to do this as of the December sales period of 2023, because that will give me a better understanding of what this user is going to be purchasing running up until December the 24th. So with a slight change in the query, you can immediately time travel back in data across all related and connected data. The important thing with that is it enables you to understand how networks and relationships change over time. It enables you to see how data has been changed from an auditing and analysis point of view. It's effectively adding a third dimension to your data. So where time series gives you event-based data, this gives you the ability to time travel across all of your data, how it looked, and see how it changed over time.